video we're going to be discussing the sign, or the SIGN sign of the values of the trig functions given angles and where they terminate in the XY coordinate plane. Okay, what I can tell you is this: it actually, your angle, depending upon where it terminates, I can tell you exactly whether or not your, say, sine, cosine, or tangent would be positive. And the reason why is because recall that when we talk about an angle in standard position, we could say some angle in standard position here. We'll call this angle theta, and I'll construct it as terminating in the first quadrant here, just for the sake of an argument here. So long as we know some point on the terminal side, and we've been calling this point some x and some y, what we could do is we can always drop down in altitude to the x-axis and form some right triangle out of this, where we know that the height of this triangle would be y, the base leg of this triangle would be x units in length due to this point. And we've been referring to the hypotenuse length, or at least the distance from the origin out to this point xy, as being this distance r. And furthermore, what I want to do is I want to kind of build an argument here. Recall also that x squared plus y squared equals r squared. Then the value of r is this. We get the square root of x squared plus y squared. Now, I don't typically write this, but I'm going to write this just for emphasis in this video. We're going to say it's the absolute value of whatever this is, because recall, when you take a square root, you get plus or minus values. We only care about the positive because this distance from 0, 0 out to this point xy, we refer to it as always being positive, okay? But knowing what we know here, we had previously in the last video constructed a new definition of the three trig functions here. We said, given any angle in standard position theta, so long as you know a point on the terminal side xy, then it is always truthful to say that the sine of this angle would be opposite over hypotenuse, or y over r, and that the cosine of this angle would be adjacent over hypotenuse, or x value over the r value, and last but not least, of course, the tangent would be opposite over adjacent, or y over x. The idea in this video is this: knowing what we know now, at least knowing that if we had a point xy on the terminal side, we could always go find r and then construct our values for sine, cosine, and tangent. I want to know in which quadrants is, say, sine, cosine, and tangent, which quadrants are they positive or negative in? And this is actually easy to discuss given the fact that, say, r is an always positive thing, because I want us to consider this. What if we had an angle, say, that terminated not in the first quadrant, but say in the second quadrant? The idea here is this, and I can go write this over here. Let's go ahead and fill this in. If I switched over to like a green, remember that in the first quadrant we have positive x values and positive y values, but in the second quadrant we have negative x values, positive y values. In the third quadrant they are both negative x and y, and then you would have positive x values and negative y values if you terminated in the fourth quadrant. You'd have a point on your terminal side that had these characteristics. But the idea is this: let's say we had an angle that terminated in the second quadrant. Which trig functions would be positive, which ones would be negative? What I can tell you is this: if you were to go find sine, say in the second quadrant, it would be equal to the y value of this point over the r value. And recall that in the second quadrant, your y values are positive. So you would be taking a positive y value divided by a guaranteed positive r value. So your sine value in the second quadrant would always be positive. Let's now look at the hypothetical values of something that terminates in the second quadrant if we were to find cosine and tangent. Now cosine, which is x over r, recall r is always positive. If we were to try to find the cosine of an angle that terminates in the second quadrant, you have negative x values. So you'd be taking a negative x value divided by a positive r value, which would lead us to believe that cosine would be negative in the second quadrant. And likewise with tangent, since tangent is y over x, and we have positive y values and negative x values, you'd be taking a ratio of two things that have different signs, so it would be negative. So in other words, the only thing that would be positive in the second quadrant, only trig function that turns out to be positive if your angle terminates in the second quadrant, is sine. What I have for us here in this video is really only just a really nifty way, or a mnemonic, to think about this here. And so you'll see that I've given three images here, three diagrams, but essentially they say the same things I've already said. We say in the first quadrant, if your angle is between 0 and pi halves, you have positive x, positive y. If it's between pi halves and pi radian rotation, you have negative x values, positive y values. In the third quadrant, between pi and 3 pi halves rotation, between here and here, you'd have negative x and negative y, and then positive x and negative y here. The simple fact is that since r is always positive, this allows us to determine very, very quickly then that if your angles terminate in these given quadrants, you can see here that in quadrant 1, then you would have all positive trig functions. Of course, x over r, y over r, and y over x, they would all be positive since x's and y's are always positive. Whereas we had already discussed the second quadrant, sine is the only thing that is positive here because it has positive y values, and everything else, cosine and tangent, would be negative, and of course their reciprocals would be negative as well. Down in the third quadrant, you'll notice that both sine and cosine are negative, but that's because you have negative x and negative y values, and using this definition, a negative here, a negative divided by positive and a negative divided by positive would be negative. Notice that tangent is positive down here because when you take a negative y value divided by a negative x value, you actually get a positive tangent value. And last but not least, the only thing that would be positive down here in the fourth quadrant would be cosine because you have positive x values, okay? So since when you notice in this pattern here, in the second, third, and fourth quadrant at least, you'll notice that only one of the three trig functions is positive and the other ones are negative. So the mnemonic that I'm going to share with you today is just this. We say all students take calculus. And this is just a really quick way to remember that really what this means is that all trig functions are positive in the first quadrant. Of course they are because you have positive x and y values on your terminal side. When I write students take calculus, you notice that I've capitalized the first letters of each of these things. When I write a capital S here, it's because sine is the only trig function that will be positive in the second quadrant. Now, I want to put in a caveat here. If sine is positive, then its reciprocal is positive. So that's why you didn't hear me say, well, sine and cosecant are the only ones that are positive. This mnemonic just kind of helps you remember that sine is the only thing that's going to be positive here. Tangent is going to be the only thing positive in the third quadrant, and cosine will be the only thing positive in the fourth quadrant. Now, knowing this is actually a really easy way to start to confront things like down here. It says, state the quadrants for which the following are true. What I want to know is this. If you had an angle in standard position, and you knew that the sine of this angle was positive, so the sine is positive, and I told you that the cosine of this angle is negative, okay, what would this imply about where your angle lies? And this will make it a lot easier to figure out. We say all students take calculus. First of all, if we say that sine is positive, it must be either in either quadrant 1 or quadrant 2. So we can eliminate the fact that our angle could not lie down here. And then if I say that cosine is negative, well, of course, it wouldn't be the first quadrant because cosine is positive in the first quadrant. But likewise, it would have to be the second quadrant because sine is the only thing that's positive in the second quadrant. Cosine is negative. So what this means is our angle, wherever it is, it has to lie between pi halves radians and pi radians, okay? It's got to be somewhere between there and there. So we would say that it is in quadrant 2, and you can just write it thusly. We say Q2. Over here, we say, okay, well, let's talk about tangent. If tangent is positive and cosecant is negative, ooh, I'm using a reciprocal trig function here. We still have all students take calculus. Let's start with this. If tangent is positive, so where could this be? Well, of course, everything's positive in the first quadrant. It couldn't be the second quadrant because sine's the only thing positive here. Could be the third quadrant. Could be. We said tangent's positive down there. But it couldn't be the fourth. So now between the first and the third, which one is it? Notice that I said cosecant is negative. The important thing to recognize here is that if a trig function is negative, then its reciprocal is also negative. So where of these two quadrants would sine be negative? I would have to say that it's the third quadrant because, again, tangent is the only thing positive down here. So we say it couldn't be the first quadrant. I'd have to have some angle that terminates down here. This is some arbitrarily drawn angle. Here's our theta. But it would have to be between pi and 3 pi halves radians. Whatever our angle is, it'd have to be between those two measurements. So we would say quadrant 3 is where this lies. Okay. So where does this come in handy? Well, a lot of the time, you know, let's say we're given the value of a trig function here. We know that tangent of theta is equal to negative 5/4. What we want to do is we want to go find the value of some other trig functions, but now we've opened up the door to the fact that some of our trig functions may be negative depending upon where we lie, and we weren't necessarily told where this angle lies. So what we're going to do is this. We're going to start by saying, well, if tangent is negative 5/4, recall first of all that this is very true. Tangent is y over x. So tangent is negative. Either y is positive and x is negative, or y is negative and x is positive. So as far as where this angle lies, we still kind of, don't know where it's at. I just know that x and y values have to have opposite signs. So we're either in quadrant 2 or quadrant 4. How can we narrow this down? Well, what we've been told is also this. Tangent is negative, so we say all students take calculus. It couldn't be here because tangent is positive there. But I was also telling you that cosine, whatever that is, the cosine of this angle is positive. So where would the cosine be positive and at the same time tangent be negative? We must be in the third quadrant, okay? So the next thing I'm going to do is this. I'm going to encourage everybody here to sketch a picture of your angle. As a matter of fact, here is our theta. Okay, and what I want to do is I want to go find the sine and secant of this. Now, the reason why that knowing the tangent of theta is negative 5/4 is so beneficial is because recall this. If you're telling me this, then what you've really told me is information about the point on the terminal side. And as a matter of fact, that's what we need to know in order to go find our other trig functions. So we know that y is either -5 or +5, and x is either -4 or +4. Well, let's look down here. If I have a point on the terminal side, I'm going to make a triangle out of this here. I would say that I know that y is 5, and I know that x is 4, just because I've been told that by my definition of tangent here. But I know that the y value is the one that has to be the negative one. I'm going to try to sketch this in here for you. Y has to be the negative one. There we go. So if that's the case, then we know x is 4, y is -5, r is going to be the square root of 4 squared plus -5 squared. So we get this, we get 16 plus 25, we get the square root of 41. And I know that the square root of 41 must be positive. And now that we know these, when I ask you to go find, say, the sine of this angle, recall that the sine is y over r. So we could take our y value, -5, over our r value, square root of 41, which is this right here. We say r is the square root of 41. And we can say, yeah, we get this right here. And as a matter of fact, we should rationalize this. But the point to notice here is this. We're able to go find this by sketching a picture, and it's negative. Sine is negative down here. Of course sine is negative down here. Cosine is the only thing that's positive. And then likewise with secant. We say, if I want to go find the secant, let's do this first. We'll go find the cosine first. And the cosine would be x over r, and our x value here is this 4. We say we knew that it was 4, and our r value is root 41. Now I'm going to make a suggestion here. Now I should rationalize this, and we're after secant is the thing here. I should rationalize it, but since we're after secant, my suggestion is going to be this. Let's just go ahead and flip it now. We'll call it root 41 over 4. And the only reason I tell you to do that is because if you were to rationalize this and flip it over, then you got to do some simplification, and you just end up with root 41 over 4 anyways. Okay. So let's try another one here. We say sine is 4/5 and tangent is negative. Let's go find the cosine of this angle and the cosecant of this angle. So first things first, let's go sketch our angle. We've been told this information. We say all students take calculus. Well, sine is positive, so I either have to lie in the first quadrant or the second quadrant. I couldn't be down here or here. And also this, tangent is given to us as being negative. So where would tangent be negative? Well, it wouldn't be in the first quadrant. So our angle is somewhere over here. Now I should draw this to scale, but I'm just going to draw an arbitrary angle right here. We say that this is the angle theta. And what I'm telling you is this, because of by our definition, we know that sine is this y over r business. Then I can tell you that telling me that this is 4 over 5 really does give me insight into what point was on the terminal side of this angle. As a matter of fact, I know that the y value, let's talk about this here. Here's our point xy, and we have some r value here. I'm going to drop my altitude. But essentially we know this. Our y value must be 4. And our r value must be 5. The only thing we don't know, this is 4, see, we don't know x. Okay, and what we're going to have to do is we're going to have to go solve for this unknown x value on the terminal side. So I'm going to go ahead and fill these things in here. We say y is 4, r is 5. Let's go solve for x, and this can be easily done by just using Pythagoras. We say, well, x squared plus y squared is equal to r squared, where we know that y is 4 and r is 5. Okay, so we get x squared plus 16 here, is equal to 25. If we subtract 16 from 25, we actually can reason that this is 9. And so taking the square root of that, we get plus or minus 3. So now, why? Why do I care so much about the signs of these things, SIG and sign? Is because, look, we got a plus or minus 3, and we got to decide which one's appropriate here. And looking at this, if you drew your picture, which you should do, we should know that the x value has to be actually the negative value here. So we say x is -3. And again, once we know these 3 values and we have our image here, we can go ahead and go find for the solve for the unknowns that we want, which were cosine of theta, which is x over r. Recall that our x value is negative here. We get -3 over our r value, which is +5. So we get a negative cosine value, a -3/5. And if we were to go find now cosecant, well, I'd have to go find the sine first. Recall that we knew that the sine was 4/5. So if we wanted to go find the cosecant, we could say, well, then the cosecant must be 5/4, and it is also positive because sine was positive in the second quadrant. So that is how you know which quadrants your trig functions are positive and negative in. Cheers.